All right, boys and girls, welcome back to the drive-through. As we continue on our journey in Chapter 3, Algebra 1, I love this little video here. This is a good little set of problems. This is why you learn math. So, pause the video, and I want you to read the story about Allie and Dane and their water park. Okay? Hopefully you've now read it and you recognize that Allie's, so we're going to make as many observations as we can. I'm just going to make them out loud. I'm not going to really write anything down. So, Allie's pool started with a greater amount of water in it than Dane's pool had. And those are our y-intercepts. It's where we begin the problem. Okay? I also observed that Allie's pool is draining at a faster rate than Dane's pool is. And what that means is that Allie's slope is more negative than Dane's. I know that the domain for time is that it must be positive and that it eventually comes to an end. I know that this is the maximum for Allie's graph. This is the maximum for Dane's graph. I know that this is the point of intersection, and that at that point the amount of water in both pools would be the same amount of gallons. And that's about what I observe. Oh, I noticed that they're both continuous functions. They're continuous. They're not step or discrete functions. Okay, so hold on, let me get back to the beginning here. So, part 2. We're done with part 1. Dane figured out that the pump he uses drains water at a rate of 1,000 gallons per minute, and it takes 24 minutes to drain. Write the equation to represent the draining of Dane's pool. What does each part of the equation mean? Well, let's see. How many gallons did we start out with? If we have 1,000 gallons per minute and 24 minutes to, so 1,000 gallons. Check out this. This is some of the stuff you've been doing in science. In 1 minute, okay, times 24 minutes, that's going to give us how many gallons we started with. So that is 2,400 gallons. Well, that's how many we started with. That is our y-intercept. So, and that's for Dane. So 24,000 or 2,400. So how many of these are there? 1, 2, 3, 4, 5, 6. Well, that means that each step is worth 2,400 divided by 6, which is 600. Sorry. That is 400. Jeez, oh Pete. It is 400. So I'm just going to put an 800 on the second one. Skip one, put a 1600 on the third one, and we have our 2400 on there. So what is our equation, d of x? Well, let's write it in mx plus b form. What's m? It's the slope. What's the slope in Dane's problem? Well, it's negative 1,000. So negative 1,000x. What's the y-intercept? It's where we begin, so plus 2,400. Okay, based on this new information, correctly label the graph. All right, so we've done this side, and we know that it takes 24 minutes for Dane's to drain. So this is 24 because it's drained. How many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like each one of these is 1 minute. I am so sick of this, of writing on this terrible Interwrite board. I miss my board. Let it be known. This ViewSonic is the worst. Okay, So each one of these is 1 minute. Each one of these is 400 gallons each unit. And that's normal in graphs to have the units different. Okay, so we've got the information labeled. For what value of x makes sense in this situation? Use interval notation. So we could say x goes from 0 to 24. You can write it like that, or you can say x is less than or equal to 0, greater than or equal to 0, and less than or equal to 24. Determine the range or output values that make sense for this situation. Use the interval notation. So, well, y goes from, we still go from lowest to highest, so we're not going to say from 2400 to 0, it goes from 0 to 2400. I would also accept y is greater than or equal to 0 and less than or equal to 2400. Okay? Write an equation used to represent the draining of Allie's pool. Use interval notation. Okay, so let's do all the same stuff for Allie's. Well, where's Allie's start? It starts 400 higher. So the B for Allie's is 3,000. Okay, let's find two points to find the slope. So 0, 3,000. And another point on Allie's would be 24, 23, 22, 21, 20. So 20, 0. So that means that Allie's 3,000 gallons drained in 20 minutes. So the slope is going to be 3,000 minus 0 over 0 minus 20. And so that is, let's see, 3,000 divided by 20. Oh my gosh, at this point I realize I've been off by a unit the whole time. This should be 24,000 gallons. Right? Maybe you caught that way earlier than I did. Okay? This should be 24,000. Okay? And this should be 30,000. So, it is, the slope is 1,500 per minute. 1,500. Okay, there we go. Sorry about that. Okay, the range, or the domain for the x's will be x goes from 0 to 20, and y goes from 0 to 30,000. Okay, on to part 3. Based on the graph, where does A of x equal D of x? Well, right here at this intersection point. Yeah. So, when does that exist? Well, on the graph, it looks like we're going to have to kind of estimate it, and later on in the chapter, we'll find out exactly how to find the intersection point. We've kind of actually done that already, but 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, so it looks to me like that is the point. 10 minutes, comma, let's see, 400 800, 1200, 1600, so I think that's 1400 gallons. 14,000 gallons. So, what does that mean? After 10 minutes, each pool will have 14,000 gallons. Okay, what is A of 5? A of 5. Well, that is the value of the function A when x equals 5. So I got to find 5 minutes and see where A of 5 is at 5. A of 5 would be 400, 600, 400, 800, 1200, 1600. About 20,000. How would I find A of 5 actually? If I didn't want to use the graph, I would use the equation. What's our equation? It is, where do we write that down at? We never did. So, A of x is negative 1500 x plus 3 plus 30,000. Okay. So, A of 5 will be negative 1,500 times 5 plus 30,000. And it's actually going to be 22,500 gallons. So our estimate was pretty significantly off. If d of x equals 2,000, so let's forget about the graph, but let's just see, when does d of x equal 2,000? 4, 8, 12, 16, so it's right about here. God, I can't even draw a straight line on this thing. 1, 2, 3, 4, 5, 6. So about 6 minutes. Let's figure that out. So when does d of x equal 2,000? 2,000. Oh no, 2,000. 2,000. Well, let's just pop it into the formula. So negative 1,000x plus 24,000, right? Yeah. So 2,000 equals negative 1,000x plus 24,000. We got to solve that bad boy. So subtract 24,000 from both sides. And you get negative 22,000 equals negative 1,000x. Divide each side by negative 1,000, and you get x equals 22. So what does that mean? That means after 22 minutes, oh yeah, we did 20,000. They wanted 2,000. So after 22 minutes, let's see, Dane will have 2,000 gallons left, so he'll almost be drained. Okay? When does A of x greater than D of x? Up until this point. And I'm just going to end the video at that. Come see me if you have any questions. You're doing great.